morning, everyone. Welcome to another awesome episode of Valenzuela FB Live for Science 10. Are you all excited in today's discussion? Are you ready for new discoveries and learnings that will make you wonder? If you are ready, let's begin. Today's topic will focus on the seafloor spreading and magnetic stripping. After this lesson, you should be able to describe seafloor spreading theory and explain how magnetic stripping on the seafloor provides evidence for seafloor spreading. Did you ever imagine life without this COVID-19 pandemic? The weather is just right to go out. You feel the breeze of the air and walk along the beach. It's summer. Where do you usually love to go during summertime? Type or key in your answer in the comment box. I see different answers. Somebody said, Boracay. Wow, that's a nice place. Most of you choose to go to beaches. You love to see different bodies of water, sea, ocean, and the like. Same here. I also love to go to the beach and have some fun. Do you look at the surface of the water? Do you know what happened at the bottom of the sea? Why is the seafloor, as what we've seen in the picture, not a flat surface? Why are the rocks in one continent matched with the rocks in other continents? Why are continents separated? Alfred Wegener tried to explain the answer behind this, but his theory was not accepted until 1960. Why? Let us try to investigate further. In 1912, Wegener proposed the continental drift theory. He believed that continents were like a jigsaw puzzle that fits together once joined into a supercontinent called Pangaea. But as I said earlier, his theory was not accepted because he failed to explain how the continents move. In short, he has no proof. This made other scientists to investigate further, and one of them was Harry Hess. Harry Hess was an American geologist, professor, and a Navy commander. One of his functions was to study the deepest part of the ocean floor with the use of sonars and submersibles. Hess, together with other scientists, discovered mountains in the ocean floor similar to those found in the continent. It is called mid-ocean ridges. One of them is the famous Mid-Atlantic Ridge, an undersea mountain chain in the Atlantic Ocean. Yes, you heard it right. Mountains under the ocean. The question is, how is that possible? Harry Hess studied about it and realized that maybe Alfred Wegener's theory of continental drift was true. So, in 1960, he proposed the seafloor spreading theory. And what is that? Seafloor spreading is a process in which a new seafloor is created as the old ocean floor sinks. The magma rises to the surface at the mid-ocean ridge. As the magma tries to escape, it causes the seafloor to spread and make room for it. When the magma escapes, it flows to the side of the seafloor. And when lava cools, it creates a new seafloor. The old seafloor is destroyed at the subduction. So, this is the proof that the plates move along on a conveyor belt. So Wegener's idea on continental drift was correct. What do you think is the evidence of the seafloor is spreading? Yes, it is the discovery of the magnetic strips on the seafloor. Magnetic strips are magnetized pattern of rocks on the ocean floor. So, how does it happen? Why is there a strip on the seafloor? Is there a magnet at the bottom of the ocean? To answer those questions, let's look at the picture of the Earth. What are the two poles of the Earth? Key in your answer. Very good. Geographic North and Geographic South. Do you know that there are other poles? Yes, they are magnetic north and magnetic south. Earth is said to be a giant magnet. The Earth's magnetic field is generated in the very hot molten outer core and has already existed since the birth of our planet. What do the travelers use to locate the direction on Earth? All right, a magnetic compass. It tells us the directions on Earth. It also proves that the Earth has a magnetic field. Magnetic compass always points to the north, specifically the North Magnetic Pole. Did you know that the North Magnetic Poles and South Magnetic Poles sometimes interchange? It is called magnetic reversal, or the flip of the Earth. So how does it happen? This happens when the Earth changes its North Magnetic Pole to South Magnetic Pole, or vice versa. And this is due to the change of the directions of the flow on the outer core. The Earth flips 180 degrees. Over the last 10 million years, there has been an average of 4 to 5 reversals per million years, or once in every 200,000 to 300,000 years. It has been 780 years since the last time it has been reversed. 780,000 years. Where the North and South poles are located as they are to be found now, it is called normal polarity. When the North Pole and South poles are located in the opposite direction, it is called reverse polarity. During World War II, during the time of peace, magnetometers were attached to the battleships to help search for underwater submarines. They discovered that the seafloor rocks show a pattern of normal and reverse magnetic polarity alternating across the ocean floor. It is amazing that the stripes on both sides of the seafloor are of equal size and polarity, which seem to be mirror images across the ocean ridge. How is this possible? Molten materials contain iron. When they cool, the iron bits line up to the direction of the Earth's magnetic pole. They behave like tiny compasses. When magnetic flip occurs, there is also a change of the polarity of the rocks. This pattern also shows the age of the rocks. The youngest rocks are located near the ridge, while oldest rocks are located far from the ridge. So, what does this magnetic strip on the seafloor indicate? It indicates that the seafloor is indeed spreading. Now, let us find out if you remember these terms. Let's call this activity Buy Me a Vowel. You will supply the missing vowels to complete the word or words presented on the screen based on the given definition. Type or kill your answer in the comment box. You are given 5 seconds to do that. Are you ready? Let's begin. Number 1. Situation in which the Earth's north and south poles are aligned as they are now. Did you get it right? It's normal polarity. Number 2, long chain of mountains that run through the middle of the ocean. Okay, mid-ocean region. Number 3, there are magnetized rocks on the seafloor. All right, it's magnetic strip. Number 4, mechanism by which continental drift occurs. Correct. Seafloor is spreading. Number 5, magnetic flip of the Earth. Yes, it's magnetic reversal. Did you find it interesting? Let's have another one. This time, you're going to complete the sentences or paragraphs on the screen by filling in the missing words. Choose your answer from the words inside the box. I will give you 5 seconds to answer each number. Key in the missing words in the comment box. Let's do number 1. Blank proposed the seafloor spreading theory in blank. Very good. Harry Hess proposed the seafloor spreading theory in 1960. Number 2. Seafloor spreading is a process in which a blank seafloor is created at the blank as the old ocean floor blank at the blank. Okay, let's check your answer. Seafloor spreading is a process in which a new seafloor is created at the mid-ocean ridge as the old ocean floor sinks at the subduction zone. 3. Earth is a giant blank. The poles of the Earth flips are called blank, where the north becomes blank and the south becomes blank. Let's check if you are correct. Earth is a giant magnet. The poles of the Earth flips are called magnetic reversal, where the Earth north becomes south and the south becomes north. 4. The blank pattern on the ocean floor resulted from the magnetic blank of the Earth. The stripes on both sides have the same blank and blank. This indicates that the seafloor is blank. Okay, so what's the correct answers? The magnetic pattern on the seafloor resulted from the magnetic flip of the Earth. The stripes on both sides have the same size and polarity. This indicates that the seafloor is spreading 5. The magnetic pattern also shows the blank of the rocks. Youngest rocks are located blank the ridge, while oldest rocks are located blank from the ridge. Again, let's see if you are correct. The magnetic pattern also shows the age of the rocks. Youngest rocks are located near the ridge, while oldest rocks are located far from the ridge. Congratulations! Congratulations. You are amazingly brilliant. You did a good job. We're almost done with our learning journey today. To sum up, Harry Hess proposed the seafloor spreading theory. Seafloor spreading is believed to occur as hot magma rises at the mid-ocean ridge. This magma cools down and becomes the new seafloor. The old seafloor is destroyed at the subduction zone and melts inside the mantle. The magnetic stripes in the ocean floor and the age of the rocks support the seafloor spreading theory. To further improve your skills about the lesson, you may answer the activities in your learning packet or module. Your discussion teacher will ask you to do activity 2 on pages 23 to 24. If you have questions or you want to clarify something about what has been discussed, you are free to key in your comments in the comment box. I will answer them as much as I can. A minute will be given to you to type or key in your questions, and our teacher moderator will be gathering them. Your 1 minute starts now. Your time is up. Let me read the first question coming from Parada National High School. Question number 1. Is the Earth getting larger and wider when plates drift away from each other? Nice question. The Earth's size does not change. It's, it does not getting larger or smaller. It is because when the new seafloor is created at the ridge, the old seafloor is pushed and destroyed at the subduction zone. Okay? So let's read the second question from Dalandanan National High School. What is the role of the mid-ocean ridge in the movement of lithospheric plates? Interesting question. Actually, the mid-ocean ridge serve as the origin of lithospheric movement. It is the place where the force that pushes the lithosphere originates. Question number 3, coming from my son National High School. What is the importance of seafloor spreading? Another interesting question. If you can recall, in 1912, Alfred Wegener produced evidence that the continents are in motion. But geologists rejected his ideas because he could not explain what forces caused them to move. Almost 50 years later, in 1960, Harry has confirmed Wegener's ideas by using the evidence of the seafloor spreading, like magnetic stripping on the seafloor, age of the rocks, to explain what moved continents. It's like the idea of wedge in his continental drift theory, plus his seafloor spreading, yielded to the idea of the plate tectonics theory. You were all doing great. May you have a great ACA morning ahead. Thank you and keep safe.